All right, let's talk about naming hydrocarbons. Hydrocarbons, first of all, are things that have molecules that contain carbon and hydrogen. Later on, we'll be also including molecules that might contain an O or an N or some of the halogens like F, Cl, Br, and I. But for starters, we're going to keep it simple. We're going to talk about hydrocarbons. Names have three parts: prefix, root, suffix. I'll walk you through each part. The root, we need to figure out the longest chain of carbons. So for example, this is a 4-carbon molecule, and therefore the root that I would be interested in would be bute. Okay? Fairly straightforward. Next up is the suffix, the ending, what I'm going to stick on the end after this. And question you have to ask yourself is there only single bonds in the molecule? If there are only single bonds in the molecule, we would use the ending A-N-E. If there's a double bond somewhere in there, we would use the ending E-N-E. And if there's a triple bond somewhere in there, we would use a Y-N-E. We'll only be looking at these three endings for now. And then there's a prefix, what goes out in front. Often off of one chain, we have smaller hydrocarbon branches, and we're going to need to locate them properly. The best way to do this is by following through on some examples. So let's try some together here. I see 1, 2, 3, 4 carbons in a row. Scroll up. 4 carbons is bute. Are they all single bonds between the carbons? The answer is yes. I'm going to use the ending A-N-E from right up here. And then I have to ask myself, is there any carbon branches sticking off of this chain? And the answer to that is no. Straight up, 4 carbons in a row. Butane, done and done. Wait a second. Check. Let's take a look at this guy here. I've got 1, 2, 3, 4, 5, 6 carbons in a row. My chart tells me that this is going to be a root with hex. I do see a double bond in here, so I'm going to be using the ending E-N-E. E. Now, the double bond is here. It's not here, or here, or here. It's here. Where is it? It's attached. It's in between the first carbon and the second carbon. I can start counting from either end. So in this case, I'm going to count from over here. So it's between carbons 1 and 2, so I need to locate where that double bond is. So I put the number 1 and a dash. The 1 represents, it tells me that the double bond starts on carbon 1, ends on carbon 2. And I use a dash. Dashes always separate numbers from words. Let's go to the next guy. I see here, and often what I suggest to students is that they circle the longest chain that they can see. When I circle the longest chain, I see that right there. Yes, some might say, whoa. Okay. Some might say that this is the longest chain, and you are correct. We're going to get to the same answer in the end anyways, almost all the time. So I've got a 3-carbon chain. I go up here, I see that 3 carbons is prop. Are they all single bonds? Answer, yes. I use the ending A and E. But now I've got, something all around. So if I decide that I'm going to be looking at this, focusing on this guy as my longest chain, I got this little 1-carbon branch bud sticking off here. It's 1 carbon long, so I'm going to use the same chart for my up here for my roots. It's one carbon. One carbon is meth, except all branches don't use these endings. They use the ending YL. So I'm going to have a methyl group. Oops. Let me go back to black. I got a methyl group here. There's the root. There's the ending for all branches, methyl. This is methyl propane. Question is where is the methyl? Just like I had to say where the double bond is right here, I need to say where the methyl is. Where is it? If this is 1, that's 2. So I need to say that the methyl group is off number 2. Next guy, longest chain. Again, I'm going to switch colors and I'm going to circle it just like that. Longest chain is 5. The root for that is pent. Are they all single bonds? Yes. I'm going to use the ending A and E. Do I have any branches sticking off? Yes. I have 2 methyl groups. Second time for that. 2 methyl groups sticking off. So, and where are they? They are off number 1, off number 2, and number 3. I'm not going to count here. 1, 2, 3, 4. I could use 3 and 4, or I could use 1 and 2. And the rule is use the lowest set of numbers. So I'm going to call this 2, comma, 3, dash, di, methyl. Okay. 1 methyl group off number 2, 1 methyl group off number 3. Commas separate numbers from each other. Dashes separate numbers from words. A little die in here because there's 2 of them. Seems kind of redundant because I put 2 numbers here, but that's the rules. Next guy, I'm going to circle the longest chain. Now I've made them all fairly straightforward. I kind of put the longest chain for the most part. What the heck? Put the longest chain for the most part right horizontal in front of us. But this guy is 1, 2, 3, 4, 5, 6, 7. My little chart tells me that's het. Are they all single bonds? Yes. I'm going to use the ending ane. I've got 2 groups. This again is our friend the methyl group. This is 2 carbon chain. If I look up on my chart, that's F with ending YL makes it an ethyl. This is an ethyl group. That's a methyl group. Which one am I going to put first? Some might say you should put the bigger one first. And actually what we do is we put them in alphabetical order. Ethyl with an E, methyl with an M. This guy's going to go first. I'm going to start counting from this side because that makes us 1, 2, 3, and 4, not 1, 2, 3, 4, and 5. Lowest numbers are from over here. So I'm going to say that this is 3 ethyl, using dashes to keep numbers separated from words. 4 methyl heptane, and this is all one word. Okay, all one word. Next guy, I'm going to look for the longest chain. There it is right there. I'm pretty sure it's 10. I've got a methyl group sticking out of here, another methyl group here, and an ethyl group right here. Make sure that you want the lowest set of numbers in terms of which side should I count from. This would be 1, 2, 3, 8, 9. I could use the numbers 3, 8, and 9, or I could use the numbers 2, 3, 4, 5, 6, 7, 8. Which way gives me the lowest set of numbers? It's this one. So I'm going to call this still alphabetical. So that's an 8 ethyl, and a dash, and I've got 2, 3 di methyl, and then the longest chain is 10, so I use deck, and they're all single bonds. I use the ending ane. Just a couple more here. This guy has got a circle along this chain right here. Don't know why it keeps doing that. Let's do that. Try that one more time. See, my longest chain is 4 long. That's a beaut. Yes. I have a triple bond here, so I use the ending Y and E from up here when I was talking about suffixes, Y and E. Where is that triple bond? It's off of number 1. What's more important? Should I give this guy the lowest number or this triple bond the lowest number? So should I count 1, 2, 3, 4, or should I count 1, 2, 3, 4? Well, I'm using the ending Y and E here, so it's got to be pretty important. This gets the lowest number possible. So this is going to be, this methyl group is off of number 1, 2, 3. So it's 3 methyl dash 1 butane. Last guy, longest chain, nothing special going on here. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a known. I've got a double bond there, so I'm going to use the ending E and E. It's off of number 1. Yes. Still have to deal with this guy. Now this is a 3-carbon chain, but it's kind of different. I can attach a 3-carbon chain off the end, or I can attach it here. Yes. And there's in our textbook, there's a few of these special branches. Right? I call this special branch happens to be called isopropyl, and it's off of number 1, 2, 3, 4, 5. So this is 5 isopropyl. That's these are the two types of. These are the only 2 types of special branches for 3. Now, if I have 4, I could have 4 carbons in a row, and I could attach off the end guy. I could stick it on a long chain. I could attach off of this guy, or I don't even have to have 3 carbons, or the 4 carbons in a row. I could have the 4 carbons like that, and I could be attaching them off of here. So all of these guys have different names, but they're in our textbook, and you're just unfortunately going to have to remember them as they are. And that's our introduction to naming hydrocarbons.